asked to find the position vectors of P, Q, and R, okay, on this coordinate grid here. And you can, if you want, put the coordinates down. I mean, I'll just put the coordinate for P here. Okay, so you can see to P, you've got to go across for up 5. Okay, now to actually write that in vector form, remember, you've got to think about the position vector in terms of how you'd write that. Maybe we'd write OP, yeah, with an arrow above. Okay, that's how we can describe it, isn't it? Going from the origin to P. Okay, and in this case, where we've got to go across in the I direction, so we've got to think of that as the I direction, and then sort of up, then if you want, in the J direction. So we're going across for, so before I, in the Y direction, and the J, using the J vector to represent it, it'll be 5J there. Okay, for Q, so the position vector of OQ will be, well, we've got to go across here to -2, up 5. So that'll be -2I plus 5J. And then for R, OR, well, we're going to go back to -2, aren't we, down to -3. So -2 minus 3J. Okay. Then it says, so we've got the position vectors. Then it says in B, determine the lengths of the lines OP, OQ, and OR. Now, to get the lengths of them, okay, let's for instance focus on OP to begin with. Okay, to get the length of that line OP, okay, well, I've got the vector now, haven't I? OP. I've got the vector of it. So what I really want to do is find the size of this vector, yeah? So if I can find the size of this vector, I've then found the size of this line, yeah? Because remember, that line is represented by this vector, and the size of that line is the size of this vector here, the magnitude of it. Now, how do I work out the size of this? Well, if you think about it, we could employ sort of GCSE topic, yeah, and create a triangle here, okay, and we can see then when we've got a triangle, to work out a length is easy, isn't it? Especially when it's right angle, because we know that length there is 5, and we know this length across here is 4. So if we know the two sides here, we can work out the third side, can't we, using Pythagoras' theorem. Okay, so the 4 and the 5, using Pythagoras' theorem, we get then the length OP. So what I do is, right, okay, what you need to do is, you need to say, right, I'm going to find the size of this vector, okay, I want to find the magnitude of it. Now, how do you write that? Do we want to write it in words, the size of the vector? Well, you don't need to do that. What you do is, you write OP with the arrow above it, and you put bars around it, okay, just like that, right? So it's kind of locked in, and that tells us that we're looking for the size of it, right? Always put bars around it. And the question is then, well, how do I do it? How do I get that length there? Well, remember, you use Pythagoras' theorem. So Pythagoras' theorem says you square this side, square that side, and add them, okay? So, take what I've got here, 4 squared and 5 squared, okay, and of course then you've got to square that side, haven't you? But if you don't know that side, then to work out that side, you square this, add them, and then of course whatever that comes to, you square root the answer using Pythagoras' theorem, and it comes out. Now it's fine to use a calculator on this, okay, and sometimes they come out nice. In this case, it comes out to be square root of 41. Okay, so we found the actual magnitude of it there. Alright, notice when I find the magnitude, I'm still using the vector notation, put bars around it, but you don't need to put i's and j's in here then, okay? You don't need to do that, because remember, i's and j's just tell us about the direction, yeah, the direction of it. Now, when it comes to the magnitude, I'm not interested in the direction. The magnitude's then completely different, isn't it, to direction? So we can forget about the i's and j's, we just focus on using Pythagoras there, okay? Let's do OQ then. Okay, so OQ, well, let's just draw on here, this one, and then we can see the triangle here, yeah? Now again, when you see the vector OQ, you see it's -2i plus 5j, okay? So then, to get the size of it, you write OQ magnitude then, okay, by putting bars around it. Now, just look at the triangle and realize, well, actually, this length here is 2, that length there is 5, so I've got to square both of them. square both of them, add them, and then you square root the answer, and then you get OQ. So in this case, there's going to be square root of 29. Again, I'm not using i's and j's because I'm just interested in the magnitude. But also, if you notice, it's minus 2i plus 5j in the vector, but here I haven't bothered writing minus n. You don't need to, okay? Because of course, we're just interested in the lengths here, okay? And if you did write minus in there, well, as long as it's in the bracket, it'll disappear, won't it? Because when you square minus, it becomes positive. So if you wanted to, you could put minus in there, but make sure you put a bracket around it, okay? And you'll have the same answer because the minus squared disappears. So then with OR then, well, you can draw it in if you want, okay? You can see what it is. You can do that yourself, but essentially you don't need to do it, right? What you can do is just go straight forward, write the vector OR, put bars around it, and then you're going to do, right, I'm going to see that's of length 2, that's of length 3, so it'll be 2 squared plus 3 squared, and then square root it, and you get square root of 13. So you've got the size and the length of each of those vectors there.